Hello, welcome to my UROS presentation. I'm Sean Smart, and with the help of my supervisor, Dr. Manabu Sakamoto, our project was reanalysis of morphological data supporting Spinosaurus as a generalist nearshore wader. Spinosaurus was a genus of Cretaceous theropod that lived in what is now Egypt. It was named for the sail on its back, formed of the long spines of its backbone, and based on features of its morphology, such as its interlocking cone-shaped teeth and the position of the nostril being moved away from the tip of the snout. This suggested that Spinosaurus spent a lot of time feeding on fish in and around water. This was later confirmed by gut contents analysis, making it one of the few confidently semi-aquatic non-avian dinosaurs. A recent work has outlined that Spinosaurus would likely have had trouble hunting prey like a dolphin in the water and would instead have fed in shallow water similar to a stork, dipping its snout in the water with the rest of its body outside. Though there was limited data analysis on this, therefore we tried to investigate the link between linear measurements of the skull and inferred ecology of a variety of groups, or clades, with both extinct and still alive members. And then using this information, attempt to diagnose the ecology of Spinosaurus. To do this, we analysed 100 taxa from 9 clades across the ecologies, and using images we sourced from the literature and skull databases, took 6 measurements: skull length, height, width, distance from nostril to the front of the skull, distance from nostril to the top of the skull, and distance from orbit to the top of the skull. We controlled for body size by calculating a geometric mean for each skull and using this to convert each measurement into a Mosasaurs shape variable, which was then log transformed. We did a PCA to analyse where variation in size was greatest and plotted this on a morphospace diagram by both clade and ecology. The separation between clades and between ecologies was tested using a MANOVA, and this was then compared against cluster analyses which grouped the most similar taxa in absence of clade and ecology. Looking at this figure, we can see that Spinosaurus, represented by this red dot on the right hand side, fell within the larger green theropod area, with other Spinosaurs in orange. You'll also note the large amount of overlap between the theropods and the marine clades, as well as the difference between Spinosaurus and storks. All ecologies were statistically significantly different in the absence of clades, and among those groups that passed the assumptions of the MANOVA, only Crocodillians were significantly different from Spinosaurs. Both of our cluster analyses were grouped by body size, it appeared, despite this being controlled for, as mentioned earlier. The degree to which there was crossover between terrestrial theropods and the marine taxa suggests that the measurements we took were not very reflective of the aspects of the skull linked to ecology. This could have been for a number of reasons. We only took 6 measurements and that they had very high variance. Some of the skulls were as short as 5 millimeters, others like Spinosaurus were over 1 meter long. Alternatively, our resolution of 1 millimeter may not have been sufficient to capture shape information at smaller scales. So moving forward, we would suggest that other measurements are taken and tested against those we've tried here in an attempt to find ones that are more ecologically informative. In our analyses, the taxa most similar to Spinosaurus at the top was the marine plesiosaur luscan at the bottom. Despite similar orbit and nostril placement, they have very different skulls and would have been eating very different food and hunting in different ways. Finally, the persistence of size information in our cluster analyses is somewhat troubling, as it suggests that our log transformationed Mosasaurs variables did not account for this fully. The reason this is troubling is because this is a common method to control for body size when reliable size estimates are unavailable, as is often the case in paleontology. Due to such overlap between groups, we had to rethink our hypothesis, and this is challenging whenever it happens. However, in this case, it provided a learning opportunity to evaluate the basis of why we thought that first hypothesis in the first place. Furthermore, we had quite a limited pool of taxa we could use, as we couldn't use fossils with severe distortion. However, in reality, this is often quite common due to the fossilization process. I would like to thank Dr. Manabu Sakamoto. This project couldn't have been completed without him, and I thank him for his patience and for enabling me to learn so much on this project. I would also like to thank the UROS LALT team for assisting in the dissemination of this work to a wider audience and for their very helpful workshops. Thank you for listening. If anybody has any questions, feel free to reach out to me at any of the links there. And those are the references if anybody would like them. Thank you very much for watching.